Meta-analysis for data extracted from literature in Review Manager for an outcome which is a continuous or a dichotomous binary outcome. When the data extracted are in the format of binary or dichotomous outcome, then one of the different estimate of the effect size can be used. The first one is the hazard ratio, abbreviated as HR, for dichotomous outcome, odds ratio, abbreviated as OR, for dichotomous outcome, and risk ratio, abbreviated as RR, for dichotomous outcome, and finally standardized mean difference, abbreviated as SMD, for continuous outcome. In this video clip, I will show you how to perform meta-analysis on a data extracted from publication using Review Manager, and the data had an estimate of the effect size, which is the hazard ratio. Launch the RevMan, and in the window here, click on New. A new window will appear, and then click on Next, and then select Intervention Review, then click on Next, and then select the full review, then click on Finish. A new output is generated. Click on the Studies and References, and then References to Studies, and then right click, and then click on Add Study, and in the Add Study window will appear here. Is saying that which section would the study be created in. Include studies, then click on Next, then insert the first study. We'll call it study number 1, but it is 2013, and then click on Next, then click on Next, then click on Next, and then Next, and then select Add another study in the same section. Click on Continue, then insert the and type study 2, which is 2014. Click on Next, then Next, then Next, then Next, and then add another study to the same section, as I'm going to add 4 studies. Then study number 3 is 2016, and then click on Next, 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 Next. Click on another study in the same section, Continue. Then study 4, which is 2018. Click on Next, then Next, then Next, then Next, and now do nothing by clicking on Select Nothing and click on Finish. As shown here for the study section, there are 4 studies inserted into RevMan, study 1, 2, and 3, and 4. Shorten this, then click on the data analysis, and then right click and add comparison. In the comparison, let's type here, give it a name for meta-analysis for hazard ratio, meta-analysis of hazard ratio for, let's say, lung cancer LC. Click on Next. Then what do you want to do after the wizard is closed? Select Add an outcome under New Comparison, then Continue, then select the generic inverse variance, then Next, and then give it a name, let's say meta-analysis for HR. Then click on Next, and then select the outcome. Here we could select the model, whether it's fixed effect or random effect. We'll stick with the fixed effect. And for the hazard ratio option, click on names of the effect measure and select the hazard ratio. and nothing else for the rest. Click on next. Here in this section, keep the setting as it is, 95% confidence interval, and nothing to tick. Click on next, and then sort by the study ID, and then next. What to do once you've done here, click on finish. Outline is generated here for to enter the studies. So to enter the study, click on the icon here, select the 4 studies that we had entered, and then click on finished, and they will be shown here from study 13 to 18 as shown here. The hazard ratio can be added with the standard error. To add the values here, select the first study and then click on the calculator. Let's add here the lower and the upper 95% confidence interval, 0.35 and 0.95. Hit enter. Once the lower and the upper boundaries for the 95% confidence interval are inserted, then hazard ratio is generated with a standard error. Click on update data table. As shown here, the value inserted for the SE and the log HR. To do the same for the second one, select the second study, click on the calculator, enter the lower and the upper limits for the 95 CI, 0.43, and the upper is 0.69. Hit enter and then click update data table, select the third study and insert the 95% CI, 0.6 for the first and 0.87 for the second, and then hit enter. Tick on update, and for the final study, click on the calculator, insert the values for the upper and lower limits, 0.65, and then hit enter, and then click on update data table. As shown here, for each study the log HR is calculated and the SE is given here, the standard error with weight and hazard ratio as shown here with 95% confidence interval. As shown also in the area here, the method used is the fixed effects method. Could change that into random, but we'll stick with the fixed effect method. To generate a forest plot diagram, click on this icon. As shown here, the forest plot is generated with a section here for the study name and the log HR, the SE, the weight, and the hazard ratio using fixed effects method with 95% CI, and the forest plot with one here vertical line for line of no effect, and the small and several different sizes of the square here. Red square represent the value for the hazard ratio, and the diamond shape or shaped symbol is the overall hazard ratio, which is 0.62 with a 95% confidence interval. The scale is given here, and on the third section as shown here, the homogeneity test is calculated with I square and a p-value, and the overall effect size, estimate effect size, which is the hazard ratio, is significant as given here by the p-value. So this is the way to calculate and determine the overall hazard ratio for multiple studies using the REML software. In this video clip, I will show you how to do meta-analysis in REML Review Manager on data extracted or taken from research studies, and the estimate of the effect size is binary. So the outcome is binary outcome that have two levels in it, and the estimate in this case is the odds ratio, abbreviated as OR. In the REML, click on the new here icon, and in the new window, next, and then select the intervention review, then click on next and give the review a name. Let's say here meta-analysis for, let's say, lung cancer studies. Click on next and then select full review, and then click on finish, and then scroll down to studies and references. Click on references to studies and right click to add a study. So in the new wizard window here, in which section should the study be created? Included study. Click on next, then enter the author name for each study. In this case, I will just call it study number 1, which is 2013, and I'm going to insert 4 different studies. Click on next, then next. This box is filled with the year of publication. Click on next, then click on next, and then select add another study in the same section, and then click on continue. Give the second study a name, study 2014. Click on next, then next, 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 and then select add another study in the same section. Continue, back again, study number 3, which is 2017. Click on next, 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 then another next. Select the last option, continue, and then the final study, which is 2022, let's say, and then click on next, then next, another next, another next, and here then click on what do you want to do after the wizard is closed. Once you have finished entering all the 4 studies or as much as study you have, then click on finish, and then click on references to study, and if you scroll up here, you will notice that the 4 studies are added in this section. Scroll down here to the data and analysis, and then right click on it and add comparison. What name should be given to this comparison? Let's call it MA4LC lung cancer study. Click on next. Then what do you want to do after the wizard is closed? Let's click on add an outcome under the new comparison. Click on continue. Since the odds ratio, which is the estimate of the effect size, is odds ratio, then it is dichotomous. Select the dichotomous. Dichotomous outcome or variable have 2 levels in it: event happening, event is not happening. Click on next, and then let's give outcome a name, MALC odds ratio. And again, there are 2 levels here, experimental and control. Click on next. In the next window here, there are options to select from analysis model. Either can be fixed or random effects. We'll stick with the fixed effect. We'll keep the statistical method as Mantel-Haenszel. And for the effect measure, select the odds ratio. There are options for risk ratio, risk differences. We'll stick with the odds ratio. Click on next. In the next window here, set the confidence interval either for 90% or 95%. We'll stick to the default, which is 95% confidence interval for each study, and for the overall confidence interval for the overall estimate of the effect size. Click on next, and in the next window here, select how to sort the output either by study ID or effect size. Let's make it by study ID. Click on next, and then click on finish. An outlay is generated here to insert and input the values or the data for each study. Click on this icon here, and then select all the studies 2013 to 2020 and click on finish. All the studies are listed here with possibility of adding values for experimental and control, event happening, total, and event happening and total for experimental and control for all the 4 studies. Weight will be calculated and odds ratio will be generated based on the fixed effects model with 95% confidence interval and a statistical method of MH. And here there will also be a value generated for the overall effect size or overall odds ratio with the heterogeneity test performed and the p-value for the overall or pooled odds ratio. To start adding and filling the values for each study, select the first study first and then click on the calculator here, and in this section here there are places to add the values for the event in the experimental and the control and the total for the experimental and the control. For the first event in the experimental, I'm going to add 12. For the total is 16. And for the control, the event is 1 out of 25. If I hit enter, the whole values here are automatically calculated. As shown here, the total events is 13, the total participant 41, the log ratio is log odds ratio is calculated, the odd ratio is calculated with a p-value, the log of risk ratio and risk ratio is also generated with the risk differences. If I click on update table, data table, it will automatically filled here, or I can do and fill the values for the second study by filling values here. For the event is 45, for the total 60, and for the control it is 8 out of 70. So there are different ways to do it. Click on this, select the calculator, go for the third study, enter the number for the event, which is 32 out of 46, and for the control it is 5 out of 60. And then if I hit enter and then click on update data table, it is automatically filled here. Now for the final study, for the experimental event, it is 37 out of 50, and for the events in control it is 5 out of 55. Now the data extracted from all these 4 different publications, the outcome is inserted in this area here, and as shown in this section, the weight is calculated for each study, the odds ratio is calculated for each study with the 95% confidence interval based on fixed effects model and MH statistical method, and an overall odds ratio is calculated with the confidence interval. And the section here is given for the homogeneity test and the p-value. To generate a forest plot, click on that icon here, and a forest plot is generated for the 4 studies as shown here. On the left hand side, the study name and the year of publication, the event happening in the experimental with the total, and the event happening in the control with the total, the weights, the other values for the odds ratio for each individual studies with 95% confidence interval. The forest plot here shows a scale and a vertical line for one, which is a line of no effect. The each square here represent the effect size, which is the odds ratio, and the size of the square, the blue square, represent the or reflects the size of the samples. The horizontal line represent the confidence interval for each study, and the diamond shaped symbol here represent the overall odds ratio calculated from combining all the 4 studies together, and it's given here to be 27.2, and the confidence interval is calculated. In the third section here, it shows the homogeneity test for variability between studies, and the I squared is 0 and the p-value is greater than 0.05. And for the significance of this observation for the odds ratio, which is 27.2, is less than 0.05, so it is significant. So this is the way to perform meta-analysis for data taken from publications, and the outcome is binary outcome based on an effect size estimate, which is the odds ratio, to do the meta-analysis in REML. In this video clip, I will show you how to perform meta-analysis in REML, Review Manager software, for data taken from research studies that the outcome is binary. Binary outcomes have levels in it, or 2 categories, and the outcome is estimated by using an estimate of the effect size, which is the risk ratio, abbreviated as RR. In the REML, click on the new here. A new window will appear for wizard for new review. Click on next. Then in the next section, choose the intervention review. Click on next. Give the new review wizard title. Let's call it Meta-Analysis for Lung Cancer LC. Click on next. Choose the full review for the wizard, then click on finish. An output is generated here in this section for studies and references. Click on it, then click on the references to studies and right click to add studies. In the new wizard window, select the included study, then next, then start entering the author name or the label for the study. Here I'm going to insert 4 different studies, and I will give them a name of study number 2016. Then click on next, and then next, then select add another study in the same section, as we are going to add more studies here. Click on continue, then type the study number 2, which is 2019. Click on next, then next, and select the last option and click on continue. Insert the third study 2022, and then click on next, then next, select the last options, and for the final study it is 2023. Click on next, then next, and here once all the studies has been inserted, click on finish, and as shown here those studies are inserted here: 2016, 19, 22 and 23. Click on the data analysis and then right click to add a comparison. Give the wizard a name here. Let's call it MA for LC using risk ratio, and click on next. Select the outcome, add an outcome under the new comparison. Click on continue. Click on dichotomous outcomes, as the outcome is dichotomous, two categories in it. Let's give it a name, MALCRR again, and then next. In this window here there are several options to choose from: analysis model, whether fixed effect or random effects, and I will stick to the fixed one. The statistical method is Mantel-Haenszel method, and for the effect size or effect measure, going to select the risk ratio. Click on next. In the next section here, select the 95% confidence interval, which is a standard. I will go for either 90, 95 or 99. Stick with 95%. And for the each study and for the pooled overall estimate for confident interval for 95% for the effect size, which is the risk ratio. Click on next here. From these options you could select to sort out the output, either study ID or effect size or year of study. We'll stick with the study ID. Click on next, then click on finish. An outlay is generated here for inserting the data extracted from the literature, as shown here. A section for the study or the subgroup, the experimental group, which will be a value added for events and the total number or sample size, and for the control, events and sample size. Weight will be generated here and calculated. The risk ratio, the effect size that will be given here and calculated is the RR using the MH statistical method. Fixed effect models will be chosen here with a 95% confidence interval. To start adding the studies, click on this icon here and then select all the 4 studies and then click on finish, and all the 4 studies are added here in this output, and there is options to start adding the values for the events for each study. There are several ways to do it. One of the way is to click on and select the study and then click on the calculator. In the calculator section here there are a section to fill the events for the experimental and the control and the total number for the experimental and the control. I'm going to deselect the odds ratio as I don't want the odds ratio, and I'm going to select the show risk ratio calculation. And here as shown it will produce and generate the log risk ratio and the risk ratio and the 95% confidence interval with the upper and lower limits for the CI. To start entering the data for the first study, for the event in the experimental, it's 12 out of 30, and for the control it is 3 out of 35. And if I hit enter, all the values are calculated here automatically, and the log RR is calculated and the risk ratio is calculated. If I click on update data table, the values are inserted in this area. To add the values for the second study, select the study, click on the calculator and then add the values for the experimental and the control event and the total number. For the events, for experimental, it is 19 out of 40, and for the control 7 out of 55. If I hit enter and then click on update data table, the values are entered here. For the third one, I could also manually enter the values in this section. 36 for the third study out of 74, 74, and for the control it is 11 out of 61, and for the last study it is 23 out of 42, and for the control 10 out of 51. As shown here, the data now is entered for all the 4 studies with the event in the experimental and the control. Section here is given for the weight is calculated for each individual study with the risk ratio based on image and a fixed model with 95% confidence interval. And here the section is given for the pooled overall effect size estimate, which is the risk ratio. And in this section is calculation for homogeneity test and for significance of the overall finding. There is an option to change the model, either to go for random or fixed effects model. We stick with the fixed one. If I click on the icon here, a forest plot will be generated as shown in this forest plot. This section shows the study name and labels for the 4 studies, the events for the experimental, and the total number for the experimental, the events in the control with the total number for the control. Weight is calculated for each individual study, and other values are also calculated for the risk ratio for the first study, second and the third and the fourth, and a 95% confidence interval is given here in 2 brackets based on a fixed effects model and MH statistical procedure. On the right hand section here is the forest plot with the scale at the bottom. The vertical line represents the line of no effect. The bluish square here with different size represent the risk ratio for each individual study, and the size of the square represent the sample size. The horizontal line is the line for the 95% confidence interval, and the diamond shaped symbol here represent the pooled effect size or pooled RR, which is calculated here to be 3.11 with a 95% confidence interval. The significance of this finding is given here as the p-value is less than 0.05, and the homogeneity test is performed for the 4 studies to search for and examine and test and assess whether there is a variation between the 4 studies. The I-squared is 0 and the p-value greater than 0.05. So this is the way to perform meta-analysis and determine the overall risk ratio, which is a binary outcome for data extracted from literature in a REML. In this video clip, I will show you how to do and perform meta-analysis in Review Manager on data extracted from publications, and the estimate of the effect size is the standardized mean difference, which is abbreviated as SMD, and the outcome from the publications are continuous. In the RevMan, click on the new. A new review wizard will be generated. Click on next, then select intervention review and click on next, what is the title of the review? Let's call it Meta-Analyses of LC using standardized mean difference for, let's say, for lung cancer. Then click on next and then select the full review and then click on finish. An output is generated. Click on the studies and references, then references to studies, and right click on add study, and in the new wizard select the included study, click on next, then start entering the label or the author name of the publication. Let's call it a study number 1, which is 2016, and click on next, then next, then click on add another study in the same section, continue. The second study will be study 2018, and then click on next, and then next, add another study, continue. The third study is study 2020, then next, and then add another study for the final study, which is study 2023. Click on next, then select what do you want to do after the wizard close. Nothing. Click on finish and scroll up here. All the studies are inserted, study from 2016 to 23. Click on the data analysis here and then right click and add comparison. So a new wizard for comparison. Let's call it and give it a name of MALC, standardized mean difference. So the estimate of the effect size is the standardized mean difference. Click on next, then select add an outcome under the comparison. Click on continue, and since it is a continuous data that is measured on a scale, then select the continuous, then next, and let's give a name. What name should the outcome have? Let's call it standardized mean difference for LC. Then click on next, and in this section there are several options to choose from. For the model, there could be a fixed effect or random effects method can be used. We'll stick with the fixed effect. For the statistical method, it's inverse variances. For the effect measure, have two options here, either to go for mean difference or standardized mean difference. Click on next. The next section here is for setting the intervals for confidence interval, 95% as a default, and then click on next. In this section, the output can be sorted by study ID or effect size. We'll stick to the study ID. Click on next, and then after that we'll click on finish. An outlay is generated, output showing the format to enter into it the value for the two groups, the experimental treatment group or intervention group to the control group, which is the reference group. The mean and the standard deviation and the total for each group will be inserted, and a weight will be calculated, and the standard mean difference will be calculated for each individual study based on the fixed method with 95% confidence interval. To start adding the studies, click on this icon here, select all the 4 studies, and then click on finish. The studies are added here from 2016 to 23, and there are here areas to fill for the values for the three parameters: mean, standard deviation, and then the sample size. To fill this value here for each study, first of all select the study, then click on the calculator here. In the calculator, enter the mean for the experimental control, the total number of sample for experimental control, and the standard deviation for both. For the first study, the mean is 36 and the total number is 12 and the standard deviation is 5.3. For the control, it is the mean is 28 and the total number is 12 and the standard deviation is 4.9. And if I hit enter, the values are automatically generated for each group with 95% confidence interval, p-value, standard error. And if I click on update data table, the values are inserted into this area here that is corresponding to the first study. To do the same for the second study, for the mean it is 81.3 and for the standard deviation it is 8 and for the total number it is 16, and for the control the mean is 77.6 and the standard deviation is 11.6 and the total number is 15. For the third study, select the study, click on the calculator. For the experimental, the mean is 99, the number is 17, and the standard deviation is 2.1, and for the control, the mean is 91 and the number of the sample is 18 and the standard deviation is 2.2. Hit enter and then click on update data table, and for the final study the mean is 76, the SD is 3.5 and the total number is 9. For the control, the mean is 56 and the standard deviation is 3.2 and the total is 6. To generate an output and produce a forest plot, click on the icon here and a forest plot is generated as shown here. On the left section, the groups of the study from study 2016 to 23, and then the experimental and the control, the mean, the standard deviation, the total for each group with weight calculated, and standard mean difference is calculated based on the fixed effects model with 95% confidence interval for each study. As shown here, study number 2 has a confidence interval that crosses 0, so this one is not significant. In the second part here is the forest plot diagram displays these values here. Each green square represents the standardized mean difference, the value for it on a scale from -10 to 10, as the value for the SMD can be positive or negative or even can be 0. 0 means that there is no effect. So this line is a line of no effect. The horizontal line is the 95% confidence interval with the upper limit and lower limit. And if the confidence interval cross the line of no effect, then this study is statistically not significant. And the diamond shaped symbol here represent the overall or pooled SMD, standardized mean difference, and the value is 1.5 with the confidence interval given here, 95% confidence interval. The third section here shows the homogeneity test for variation among studies with I-squared value calculated of 91% and a p-value less than 0.05. So there is a high level of heterogeneity among these studies, and the p-value is also calculated for the overall effect size estimate, which is the standardized mean difference. So this is the way to perform meta-analysis on data extracted from literature that is based on continuous outcome using the estimate of the effect size, which is the standardized mean difference in REML. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, R-Statistic, or Statistics, GraphPad, Prism, G-Power, Python, and REML. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovi, R-Statistics, GraphPad, Prism, REML, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.